Next up, we have areas of circles, sectors, and segments. So area of a circle. The area is that whole inside space. All of this takes up area. Area is two-dimensional. Units of areas require squared units. Square feet, square inches, square centimeters. So it should be no surprise to you that the equation for area of a circle will be two-dimensional as well. Just like area of a rectangle, length times width. Area of a trapezoid is the sum of the bases times the height, two-dimensional. Same for area of a triangle, apothem perimeter, two-dimensional. Area of a polygon. So area is a two-dimensional thing. So your equation should have two variables to a certain point, and the units should be square units. So what's the area equation for a circle? The area of a circle also depends on the radius, and that is going to be pi r squared. Order of operations matters. You do want to square your radius. Another thing that's going to be handy is we want to leave our answers in terms of pi. What does that mean? Leave pi in your answer. If my radius were 10 units, whatever those units are, you make up your own unit, whatever you want. 10 units, okay. Well, then my area will be pi 10 squared, which is 100 pi units squared. You also could have plugged those units into your equation. 10 units for your radius squared times pi, commutative property, doesn't really matter where I put that. 10 squared is 100. Unit squared is unit squared times pi. 100 times pi times unit squared. So it does make sense that we get squared units at the end of it, two-dimensional. If you were to use your calculator and round your answer, you get approximately 314 units squared. Since you can't write pi times 100, it's going to be a non-repeating, non-terminating decimal. It's never going to end. It's pi times 100. That's where I got the 314 from, right? It will never end. This will just keep going forever. Since you have to round, you're not being precise. The type of number that never repeats and never ends is called an irrational number. Pi is a pretty popular irrational number. So by leaving it as 100 pi, you're being precise. You are giving all of the decimals of pi without needing to write them because it's defined by this symbol. Next, we have area of a sector. A sector is going to look a lot like that picture I drew a few pages ago when we were talking about arc length. But the sector part of this is the slice. The sector is just one slice of the whole circle. We're going to find the area of a sector very similar to how we found the arc length. The area of a sector is a fraction of the area of a, or the, I never know if we're talking more general, more specific, circle. So for area of a sector, now the area of a sector could be described with just, let's say, the word area, and I'm going to give it a subscript or subtext that just says sector equals a fraction of area of a circle. And what did we just say the area of a circle is? Pi r squared, two-dimensional. That's why I was talking so much about 2 dimensions, so I know it's area. Now what fraction? I could say theta over 360. I tend to think of it as the central angle because that's just the one I think of all the time. The definition describes it more as it being the arc measure, which is actually the measure of the arc itself over 360. It really comes down to being the same thing anyway, because the arc measure is equal to the measure of the central angle anyway, but whatever floats your boat for right now. Let's not worry too much about that. Let's just get the right answer. An area will also be written in units squared. Next, we're going to talk about the area of a segment. Now, I have 3 circles here because I'm really going to take 3 steps to really show you how we should be defining a segment. But let's try to be creative. A segment would be the overlap of, if we could assume that this piece of paper had a straight edge, that this is actually perfectly straight. That area that's being covered up by the paper, but it's inside the circle, that's a segment. How could I find the area of this weird little, not even like a crescent, but it's like a certain, and it's not a half. Oops, not my straightest line right there. Let me try a little bit better here. So if I color the rest of this in, how can I come up with a pretty simple, easy, nice way to define the area of this random shape over here? It looks like I took an Oreo cookie and I just sort of dipped it in milk. And I'm looking at the part of the cookie that was dipped in milk. How can I get that area? Any ideas? Any suggestions? Here's one piece of advice. One thing that always helps me out is when I'm dealing with the circle, I'm just going to trace this edge. When I'm dealing with the circle, you want to, or any geometric problem, redrawing it is really helpful. So just drawing it, let your brain sort of process using your hand, your eyes, your mind, the picture that you're looking at. Now, if I were to try to recreate this, pretend it was on the screen in front of me, and I'm doing my best to recreate it, another thing that always helps with circles is implementing some radii. So where's the center of this circle? Right about here? I feel like I want to draw a little cartoon character, like this little baseball cap. That's a nose or maybe 2 eyes. No, I don't know. I see it. Where can I draw some radii that are going to really help me out in this problem? How about right there? What kind of triangle did I just draw? If you said an isosceles triangle, well, you're a big winner today. Now, how can I find the area of this triangle? Do I know anything else about it? Now I kind of see like a fox. You know, like these are his ears. That's his nose, and these are his whiskers. And I'll draw an extra guy right there. And it's like he has like he's right over here. A backwards hat. You know, like there's that little piece, maybe his hair sticking out here. Sorry. This isn't really colored in, but I feel like it won't really look like a hat if I don't do that. Okay. That is an isosceles triangle. What else did we just talk about that might be able to help me out with this area of a segment, or the little boy and the fox? Our new geometry story. Well, I'm going to put those radii back in. So this right here is the sector. This right here is a triangle. And this right here is a hat? No, segment. How are all of these things related? So sector minus triangle equals segment, at least for their areas. So the segment is this little strip over there that you dipped your cookie in some milk. We connect it to the center. So that guy right there, that eyeball, is the center. Connect that right there, and we will get our little fox triangle. And if I can find the area of the sector, which we just talked about a few examples ago, subtract out the area of the triangle, either 1/2 base times height, or we can use some Heron's formula. And we'll get the area of that segment because it's going to be the only part that's left. Now, all of this stuff is great in theory, but for homework, you're going to have to try it and see how it goes. But before we go, I do have a little bonus challenge question for you to try. Now, I'm already giving you the answers. I gave you the area and I'm giving you the perimeter. I just want you to figure out how to get those things. Each of the two circles here passes through the other circle's center. Find the perimeter and the area of the shaded region with respect to R. So I don't need a specific radius. We'll just call the radius R. Can you get the same answers I got? Did I make a mistake? I hope that these help you, and I hope you can apply these equations and this information, these ideas to some application problems and find some success. I hope this helped. I hope you like it, and I'll see you next time.